Okay guys, Mr. Gibson. This video I'm going to show you guys how to calculate probability, and there's certain ways that we have to do this. One, if we have probability of an event A and B, the probability that they happen together, okay, that's A and B or A intersection B. When events A and B are independent, all you've got to do is take the probability of event A happening and multiplying by the probability of event B happening. Now, if events A and B are dependent on each other, then you calculate the probability of event A times the probability of event B given A. Okay, you take a conditional probability there. Now, this helps us define a formula for conditional probability. So since we have probability of A and B equals probability of A times the probability of B given A, if I divide the probability of A on both sides, the probability of A will cancel, and I get the conditional probability B given A equals probability of A and B over the probability of A. Okay, that's just another formula for you. Now, here's or probability when we have an or. So you have probability of A or B, which is the same thing as probability A union B. And here's our definition here. You just take the probability of A, you add the probability of B, and then you subtract the probability of A and B. Now, these Venn diagrams help to explain where this formula comes from, because all you're doing is taking the probability of this A and the probability of this B, just like a union, they're together. However, if you take this probability and this probability, there's a big overlap right here, okay? So to get rid of that overlap and make sure we're not double counting, you subtract the probability of A and B, okay? Because this is the intersection, the union is the whole thing. So if you subtract off the intersection, you avoid this double counting problem. Finally, we have the complement probability not B, or another way of saying that is probability of B complement. Well, what you do here is 1 basically represents 100%. It represents a whole. So anything that's not B will be the rest of the whole. So you have probability of B, you take the whole and subtract the probability of B. Again, you can kind of see it with the Venn diagram. If I have a universal set right here with a subset B, okay, the probability that's not B is everything around B, which is this whole. So 1 is the whole minus this probability here, which is B. Okay, so if it's not B, it's the part of the whole that's not B. Okay? So those are our formulas, our definitions. Let's look at a few problems. Help us out here. Alright. And I'm just going to use the calculator with these. We're not going to get into too much detail on how to multiply or add and subtract fractions. I'm sure we'll probably go over that a little bit in class, but we're not going to worry about that right now. So here's a case where A and B are independent, and we have two different probabilities. So to calculate the probability of A and B, or A intersection B, we're just going to multiply these two probabilities together. Okay, so it's 9/20 times 3/5. Okay, this I won't use the calculator because it's too easy. So I have 9 times 3, which is 27, and 20 times 5, which is 100. Okay, so that's our probability of the union, or of the intersection, A and B. Okay, so the intersection here where they overlap, where event A and event B overlap, you just multiply them together. And that's if it's independent. Now, this is the case where it's dependent. Okay, and I know it's dependent because we have this conditional probability. Okay, so in this case, B, the probability of B depends on A. Okay, so we already know that A and B Well, actually, we already know that the formula here for B given A, okay, conditional probability is 3/22 divided by 3/10. We're going to multiply by the reciprocal, which is 3/22 times, oops, that's 20 seconds, sorry, times 10 over 3. I just flipped that. If you divide by something, you flip if you divide by a fraction, you flip the fraction. Okay, the 3's cancel. These reduce down to 11/5. So it's going to be 5/11. Okay. All right, and again, just to reiterate here, this comes from this formula right here. Probability A and B over the probability of A. Okay. So that's A and B divided by probability of A. Okay, there's our conditional probability when we have some dependent events here. Now, here's a problem with not B. Okay, we're going to have to do several steps here because first we're going to need to find the probability of B. Okay, and if we remember, A probability of A and B, okay, divided by the probability of A is going to be equal to the probability of B. Okay, it's just a little manipulation from our formula. So probability of B is going to equal 9/100ths divided by 1/5. Again, multiply by a reciprocal. Okay. These reduce, and I get, that'd be 1, that'd be 20, 9/20ths. Probability of B is 9/20ths. But it's asked for not B, so what I need to do is I need to take 1 minus 9/20ths. That's 20/20 minus 9/20ths, and that's going to equal 11/20ths. Okay, got to get a common denominator. That's where I get this 20/20. 20/20 is 1. Subtract 9 from 20, I get 11. Don't mess with the common denominator. That's why we wanted to get one in the first place. Now, finally, let's look at this OR problem. Okay, we're given B, probability of B, probability of A, but we need to first find probability of A and B because that's what we have to subtract off. Okay, so how I'm going to do that is I'm going to take probability of B and multiply it by probability of A given B. Alright, so that's 1/4 times 9/25ths, and that's just going to equal 9/100ths. Okay, now we've got all the information we need to find A or B now. Okay, so I'm just going to take probability of B plus the probability of A minus this right here, probability A and B. So that's 1/4 plus 3/5, okay, minus 9/100ths, okay. Find a common denominator with these. Multiply 4 and 5 and 5. Multiply 4 and 4. Okay, so I get 5/20ths plus 12/20ths. Okay, and then minus 9/100. That's 17/20ths minus 9/100. Again, let's find a common denominator. By multiplying this by 5, we'll get a common denominator of 100. So this is 5. This is 85/100ths. minus 9/100ths. Subtract those, and I get 76/100ths, which will actually reduce down to 19/25ths, okay? Again, this part, just do it in your calculator if you want to, that's fine. But the main part is just to know the formula from the beginning, okay? So, just to reiterate, from the beginning, we had these formulas, and that's what I've been using. I've just been manipulating these formulas to get the probabilities here. Really nothing more than that. So the notes will be on the next page, and make sure you guys finish the assignment. Thanks.